Hello, everyone, and welcome to this is the second edition of Stump the Scientist. And we are super excited to be coming at you from, some of us are at Science North, taking care of animals and doing some of the things that we need to do to get our Science Center ready. And of course, some of us are coming from you at home. And where we're all located is in Sudbury, Ontario, Canada, and we are on the traditional and ancestral lands of the Tikamitching Anishinaabe and the Wanapitei First Nation. We, as always like to acknowledge the cultural contributions of our First Nations and Métis Nations in our area. These lands sit on the Robinson-Huron Treaty area, and we are all treaty people, and it's important for all of us to be thinking about what treaty area we all live in and that we are active participants in. So take a moment every day to appreciate the land that you are on and that we are on today by acknowledging the traditional territory and treaty area that you live in. And today we have got some great guests on, and I see the feed coming in on Facebook and YouTube already. The questions are coming, so let's get our scientists on board. Let's bring them all on up. I want to introduce them. As we get them on, I'll introduce myself. My name is Amy Henson, and I'm a blue coat at Science North, and one of my favorite things in the world are things that live in the water. So I am a marine biologist, so if you have any marine biology questions, I'm here. And let's see who else we've got here on the docket from Science North. We have Katrina Pisani. She's here to answer everything about your brain and how your brain works, psychology. Tyler's here. He's our physicist, space guy. He's ready to go. Who else do we have? Bruce. Very nice profile, Bruce. Bruce is a biologist as well. He's got stuff about the human body. Bruce is also secretively a mosquito expert. Yeah, interesting. We have Melissa. Melissa's here to answer things about technology and engineering and chemistry and all kinds of good stuff. And she's also a physicist as well. And we have Megan, our zoologist. Of course, I'm sure all of you have questions about animals and things like that. We've got a great docket going on today. So welcome, everybody. How's everybody doing?
Good.
Excellent. You guys are ready? I have got quite a list of questions. So here's the rules, everybody. First things first that I have to show everybody is this. We upped the ante on our trophy for this edition. Oops, don't fall off. There we go. All right.
Not the Stanley Cup?
Yeah, exactly. Yeah, I think we'll add to it every single time. So this is our Stump the Scientist trophy that you can have your name engraved on. It lives at Science North, and if you come and visit and you're able to stump one of our scientists today, your name can go on here, and then you can come to Science North. We'll even let you take your picture with it if you are able to stump the scientist. So this is what you're going for today, to have your name burned on here. The rules are, these are rules for scientists. These are really important. There's no phones. There's no Googling. There's no using your computers to answer the questions. Nothing like that. You have to use only what's in between your skull right up here. So very, very important. And the rules for our viewers today is, if you can ask a question that does have an answer to it, it must have an answer. So that is we must be able to search for it and Google at the end. On the back end of things today, we have Renata, who's joining us in the background. Renata's going to be our fact checker behind the scenes. So she's the only one who's actually allowed to use a computer and things like that. So that's kind of the rules of what we're doing today. So how do you submit questions to the scientist? Make sure you put them right in the chat. So whether you're on Facebook or whether on YouTube, we will see all of the questions that get asked. And so we're going to kind of just break right into it, because we had questions coming even before we started. And we have a question come on that's asked, how does an ion engine work? And what do they use for fuel? And Megan, the zoologist, looks a little concerned. She doesn't know, but I'm sure that we have somebody, a scientist, who might be able to answer that.
I guess I'll take it. I'm the space
guy.
Tyler,
right? Yeah, head on.
Use ion. You would not be putting an ion engine in your car, and you'll know why when I explain it a little bit more. So an ion engine, as you might expect, it's a type of engine. And in this case, it's a rocket engine. And rather than, lighting off solid fuels like the boosters on the side of the space shuttle or liquid fuels like SpaceX and burning them to create thrust, an ion engine uses ions. Ions are electrically charged atoms. So if you've ever played with a balloon, rubbed it on your head, you've given it an electrical charge because some of the electrons have come off the balloon and stuck to your hair, or off your hair and stuck to the balloon, vice versa, and you can then stick it to the wall. That's kind of fun. Well, that's generating it's obviously got a force there. So imagine we've got some ions, and usually, though not always, usually it's xenon because it's one of the heaviest elements that is easy to ionize. And you have a grid, and you squirt the xenon through this grid, which is held at very, very high voltage that ionizes them. And then there's a grid with the opposite potential over here. And the xenon ions are like, ooh, we gonna want to go, because we're ionized from the positive to the negative, we're going to zoop through. And most of them are going to miss the grid because it's like a screen door. They're going zoop right through. And then they're squirted outwards into space at high speed. And then there's an equal and opposite reaction where when the xenon's all going that way, the rocket's going to go this way. The same way you can try it for yourself. If you're in an office chair, you push your desk moves a tiny bit. You move a lot because the desk is heavier than you. Equal, opposite reactions. A lot of xenon moving fast, these ions squirted out, can move your spaceship very, 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 very gently. It's actually the strongest ion ever made, had about the same amount of push as holding a piece of paper in your hand.
Wow, that's awesome. I don't think you got stumped on that one, Tyler. That was a good question, though. I think Megan, the zoologist, and me, we didn't know the answer, so it's good. But
it wouldn't be good on Earth because you wouldn't have enough push to be able to move your car or anything like that.
Yeah, absolutely. Oh, I think this is a good debate question that could open to, I think, depending on, I don't know if it has an answer or not, but no, I think it's a good debate question. What was the most important scientific discovery?
Oh,
that's a tough one.
Well, we had an exhibit years ago, and Melissa, you led that exhibit in the exhibit hall where we talked about the one-on-one inventions that humans had made, and they kind of rated on the importance of things like the telephone and combustion engine and all that. And what was really interesting, the number one that there was a consensus of people that decided was actually controlling fire.
We had a comment from Robin about that actually on there. So absolutely. Yeah, for sure.
So I know it sounds really funny that, controlling fire today is just like whatever, but the fact that, humans were able to figure out a way to control fire, to make fire, to use fire whenever they needed, it really advanced our society, our people, our species, everything, how we ate, what we built, where we live. So maybe that is one of the most important discoveries or inventions for our species right now, is probably controlling fire, which is kind of neat.
It arguably is the most important invention, but I'm not sure you would call it a scientific discovery because it wasn't scientific. It was just like, here's this thing, it's fire. And for the longest time, people had all sorts of weird beliefs about fire. They didn't know what fire was. There's a fire spirit and we keep it alive by feeding it. And, there were and possibly are in the world still tribal groupings who have these sorts of primitive beliefs, pre-scientific thinking. Science as a way of thinking, people kind of forget this. It's very new. Like Aristotle, very bright man from ancient Greece. Everybody, used to learn about him up until a few years ago in school. But he wasn't a scientist. some people say he was an early scientist. Well, no, because the thing lacking in Aristotle is he didn't check himself. Like there's something in his writings where he said something. He's he was categorizing animals, and people say he's the father of biology. He invented biology. Well, yeah, but to be a biologist, you don't just categorize the animals. You study them. You make hypotheses about them. You go out and you look and you make sure that what you're writing down is true. Aristotle didn't do that. So he has one part where he says men are superior to women because they have more teeth. Okay, did he open his wife's mouth and count her teeth, or any other woman? Because as it happens, humans do not differ in teeth from men and women, right? And it wasn't until like Galilei in Italy in the 1600s, he was really one of the first ones to start thinking scientifically and really testing what he wanted. And one of the first ways he did this was by dropping stuff off the Leaning Tower of Pisa, to see if a heavy ball fell faster than a slow ball. Because everybody up to that point knew that if I drop something heavy, it's got to fall faster. It just makes sense. It's heavy. It's getting pulled down more. It's not true. Galileo tested that, and that was really one of the first, most important, in my mind, scientific discoveries, because it was one of the first scientific discoveries where it really showed that this idea that you can go out there and re-examine the things that everybody knows is true, that everybody knows certainly, and you can double check them and you can learn about the world that way. And that's what science is all about. And yeah, it didn't change the world nearly as much as fire did, because okay, sure, now we know about balls falling off the Tower of Pisa, big deal. But that way of thinking, that led to all of the advancements that make up the modern world, all of the scientific revolution, the industrial revolution, and everything that followed, and all the medical discoveries that have most of us alive right now. We got to, all following off of Galileo dropping stuff off the Tower of Pisa.
And here's the thing. One thing about scientific discovery is that it's not just a Eurocentric approach to scientific discovery. There were many cultures across the world, throughout the Middle East and through Asia, and of course even here in North America, that did science. They may have done it in a little bit of a different way. They may have learned about the world around them a little bit differently, but inventions were made, and we're learning that in an exhibit that we have at Science North right now called Indigenous Ingenuity, and the new inventions and things that were designed and made by First Nations people here in North America. So there are cultures all over the world who have been doing science, depending, it's been everywhere. It just may have been done in a little bit different way. So I'm not quite sure as if we can pinpoint maybe what the most important was, but I think we've got some pretty good ideas there. So thanks a lot, MJ. That's fantastic. That's absolutely fantastic. Here's a really good one. I think this is a great one for Melissa and Megan to work together on, is why do birds not get electrocuted when they sit on a hydro wire, when they're sitting on an electrical wire? Like, what up with that?
That's a great question. And Melissa, this is, I think, where you're going to confirm this, because I am not, but I'm pretty sure it's because when the bird is sitting on the wire itself, it's not grounded. So the electricity, it just sort of goes through them, but it doesn't go to the ground from there. It has to go, if the wire was suddenly to fall to the ground and the bird was still on it, then it would get electrocuted. Is that right? Sorta?
I think a little. When the electricity is passing through an electrical wire, it's insulated. So it has rubber, plastic, something around it. Tyler's nodding no. No? It's not.
No, no. The high tension lines, you go out and look at the big pylons, those are bare aluminum. And the birds still don't.
I was going to say because the electricity is trapped in the wire. That's what I was going to say.
It's a good guess. And it works with the ones, in front of your house, where they tend to be, on the way to your house. They're definitely shielded there. But the big poles, they're not. So it is a good mystery, and Megan has actually got it. So you think about it, is electricity always wants to go to ground because that's the area of lowest potential. And when it's flowing through the wire and a bird, sits on that wire, well, ground is over here on the wire somewhere. The bird's sitting on top, and the electricity doesn't want to go up through the bird and say, I'm going to zap this bird. Electricity always wants to take the shortest path to ground. And it knows that it's going to get to ground somewhere along the way if it goes through the circuit. And the bird's just going to sit up there, and it's part of the circuit, but the electricity doesn't really care it's there. It's just like, whatever. You're not on the way to ground. You're cool. And so the birds are they're just fine. They just get to chill.
So
Now,
basically they're both correct. Or am I mistaken? But both Melissa and Megan are correct, but for different reasons.
Yeah, 100%. Yeah, I suppose so.
I guess it depends on the wire that the bird is on.
But like telephone wires, you can't get electrocuted from, or no, I didn't think so. But if you have a wire on the ground, you should never ever touch it.
No.
That would cause you to be electrocuted.
That's bad news. Very bad news.
100%. Oh, that was a great answer. I love it. I don't think you stumped us on this one. You got two different answers, and I feel pretty confident about this one. Now, this is what I don't know if there's an answer to this, but maybe Katrina could help us out with this one. I don't know. Ooh, this is not my specialty, but how does consciousness emerge from the brain? Like, how do we know that we're here? Like, how do I know that I'm sitting in this chair and I'm a real person? And
okay, all of the faces that just happened are wonderful. That's an interesting question. Because I guess there's a difference between consciousness in the way that we imagine it versus like consciousness in the fact that like I'm actually awake right now and I am cognitive. I don't know that I would quantify those as the same thing. So, I mean, being awake is is a completely different thing than being conscious, I guess. I don't know how I want to answer that. Bruce, do you have any thoughts? I'm curious to know what you think because I'm trying to figure out how to
be self-aware, to be an organism that knows they're here, they exist. That's a good question.
Right.
I don't know if there's a definition. I mean, I'm pretty sure when we look at an insect, we're not looking at the same brain power as a human or an elephant or a whale. That I think we were pretty good. And I'm pretty sure the insect is running much more on, predetermined instincts or electrical impulses. There's no, I want to go there because I want to go there.
Yeah.
The funny part, that's a really good question, and it's hard to quantify what comes out of the brain. But then there's instances when you look at the animal world where you kind of look at the animals. Like, I think they are much more self-aware than what we would think of. And I'm thinking about the elephants, and the only reason I'm thinking about that is because I went to Kenya like over 10 years ago, and one thing about elephants, they recognize the future. They recognize the past events and within the present time. So a good example of that is if, for example, there's a family member that's died and they have died in a certain location or there's bones or something like that. And the families are going back and forth and they're migrating because elephants migrate. You will actually see elephants kind of stand over bones and touch them and caress them. And these are not elephants that are completely, members that are not part of the family. Like a stranger elephant won't go to the bones of another elephant and start caressing. It's family members. So to me, that demonstrates some type of self-awareness, And is it because they remember that those bones is it a question of memory, or is there a thought process of planning something in advance? So it's a really good question, and it's hard to quantify about self-awareness in that case, especially for animals. So I'm not sure if there's an actual answer to it. It's just interesting that there's not an actual answer, but as humans, we kind of look at it and almost like, I think so, but.
Well, I guess there's also different parts of your brain that do different things that also contribute to you being conscious, cognitive, having memories, having emotions, right? So, of course, your brain is responsible for a lot of different things, and it pieces it together so that you can live, and learn and have personality and have experiences and make connections. And so, again, depending, I guess it's not, I don't think there's like a straight answer. And there are different ways that your brain also connects those things together, right? So, one example that I'm thinking of, and just in terms of like, you know, thinking about brain and how you use your brain and how amazing it is, when you smell something really specific and it triggers a memory, there is a really strong connection between memories and emotions and that smell. And it's just, again, it's a really amazing way, like, as to how your brain sort of works and how you put information together and process and encode that information. But yeah, I don't know. I'm with Bruce. It's like, it really depends on, I think, what you're talking about and in what kind of terms. But yeah, there's a difference between being awake and being conscious and being self-aware. And then, of course, like, again, going into the emotion and the memory piece is a whole other ball game. So
I would say like our brain is kind of like one of these, like the study of the human brain and brains in general are kind of one of these pieces of science that we're still learning so much about, right?
Yes.
Like there's so much we don't know about how our brains work and function and how they work together. And it's a huge, huge undertaking to sort of discover all of that kind of stuff, right?
Yeah,
for sure.
Yeah.
All right. Well, I don't know if there's really an answer to the consciousness question. I don't think you can stump us on something that there probably isn't really an answer for, but that was kind of a cool question. I liked it. Now this is a great one. This is coming to us from Seb and Skylar. How do black holes form? Oh, because lots of space questions going on in the chat, but I like black holes. They're kind of dark and mysterious, and I don't know. They suck things into them, I think, and I don't know. They're kind of cool.
So there's two kinds of black holes, and they form in different ways. There's primordial black holes, which are like that supermassive black hole at the center of our galaxy and at the center of most galaxies. You may have heard last year, or maybe it was the year before, time blurs during a pandemic, that we got a picture of a black hole. And that picture was of one of these supermassive black holes. It was in the middle of a galaxy and it looked kind of like the Eye of Sauron, very creepy looking thing. And those actually, they're called primordial because that word means first. They actually formed very early, at the very first beginnings of the universe. More or less, the Big Bang happened and it spat out some black holes. And when the universe was young, stuff was really packed close together. If you're not familiar with the Big Bang Theory, everything started in one spot and went boom and expanded outwards. And so everything was packed really close together. So any black hole that got formed then had a lot of stuff really close to gobble up, and it got bigger and bigger and bigger. And they got big enough that they actually had the gravity to sort of be the seed that the galaxies, like ours, formed around. So that's one, the primordial black holes that formed after the Big Bang. Two is probably more common, we think a lot more common, are stellar remnant black holes, which you might get from the name, have something to do with stars. So if you have a giant star, like an O or a B type, maybe the larger A type, I can't remember, star, like a star over a certain mass, because there are stars sort of fall into different types, but the really big, heavy, blue, supergiant stars, when they get really old and they run out of fuel, they collapse in on themselves. Every star does, right? But smaller stars, when they collapse, they don't have enough gravity in their collapse to form a black hole. They'll form something else. There'll be some force in the universe strong enough to hold up against the gravity of the matter in the star, be it electron pressure to make a white dwarf or neutrons to make a neutron star. But if you have a massive enough star, nothing can hold up against all that gravity when it dies. It's not really alive, but we say die. When it runs out of fuel, it's being held up by the light pressure, basically, of the coming out of the star. It's fluffing out the star. When the lights go out, everything goes in, and you get a big boom. That's the supernova. But what has fallen in can collapse and make that black hole, and that's the stellar remnant black hole. And it's all the stuff that used to be that star that is just can't hold up under its own weight without the energy of the star. So I've probably over-wordsed that, but there you go.
That's very cool. I didn't know that there were two different types of black holes. I just assumed a black hole was a black hole was a black hole.
I mean, they're the same thing. It's just two ways to form a black hole. And so the categorization comes from that. If you saw a baby primordial black hole, one that hadn't gotten super big, next to a stellar black hole of the same size, you wouldn't be able to tell them apart. But the primordial black holes are super ginormous. Like, instead of being 20 to 100 times the size of the sun, they're 20,000 times the size of the sun.
Oh man. All right. Well, that was a great answer. Don't think we stumped our scientist on that one. Sorry guys, that was a great question though. I loved it. All right, so here's another. This is kind of neat because I have a lot of these in my backyard. I have many fruit trees. I have cherries, I have plums, I have apples, and every year flowers come out, and then I get apples or cherries or plums. How is fruit made? Like, how does that happen? Like, why is it a flower one second and then an apple the next? Well, it takes a few months, but you get what I mean. Anybody have an answer for that?
I can crack at this one.
Crack at it, Megan.
Yeah, so basically the fruit, if you can kind of think of it as part of the flower, but it sort of has to get pollinated first. So when your apple tree is in bloom, the pollinators, like bees, butterflies, right? They pollinate that flower. So the pollen from another flower from the same species goes onto the flower, onto the female parts, and then makes it like a baby, but it comes with fruit instead. So it's really kind of cool because if you have a crabapple tree or an apple tree in your yard, if you go out right about now, because on mine at home there are no more flowers on it, but you can see just the little tiny baby apple sort of just starting. And our chokeberry bushes outside here at Science North as well, there's only a couple of flowers left, but right where the flower was, sort of at the base of where the petals were sticking out, there's now a little round ball, which is the start of the actual chokeberry.
Yeah, I have my apples are about the size of my thumbnail right now. They're there. They're small.
Yeah. But the key is the pollination. You won't get the fruit unless the flower is pollinated.
Yeah, and so it was in the comments. I think it's David. David says that trees have gender, and you're right. So there are some plants, right, that have both male and female parts on the same plant. But there are some plants out there that you need two separate plants, and one would be the male plant, and then the other one would be the female plant. So ones that you might know of would be like holly bushes. So holly, like we might see at Christmas time, in decorations, you need a male plant and a female plant in order for the holly berries to pollinate and get those berries, which would be the fruit, right, at the end. And in Northern Ontario here, the other plant that you would see if you're hiking around on some of the outcrops, rock outcrops, is juniper. Juniper as well needs to have a male plant and a female plant, which is kind of cool. And then other plants, they are kind of all in one, which is kind of neat. So I think that's kind of cool part too. That's awesome. Thanks, Megan, for that one. That was great. Now, okay, guys, I'm really sorry. I feel really bad. I think this might, I don't know. I'm hope maybe one of you knows the answer, but I'm like, So Evelyn's asked us a question. And I'm worried about it. And the reason why I'm worried about it is because we don't have a geologist here with us today. No! So I'm a little worried. But so Evelyn, you might actually stump some of us. I'm not sure, but I'm going to ask the question. How do geodes form? And I don't know the answer to that. I just know they're super pretty.
That's a great question. And it's a really fun answer.
Is it? Do you know the answer? He does. Ah.
So when you have a geode, the key to the geode isn't the roundness, but the roundness is cool. The key to the geode is that there's crystals inside another rock. The ones they sell you are round, but they actually come in all shapes. It's round because that's actually like a bubble that's either been eroded out or was actually in the rock originally, depending on the type of rock. When I mean eroded out, it means that there's been water flowing through the rock, probably hot water from like a hot spring. And when I mean in the rock originally, I mean if the rock came out of a volcano, it's going to have bubbles and voids in it, right? Air. But the way the crystals grow in it, these tend to be quartz crystals. The one almost, not exclusively, but generally the ones in the gift shop I see are always quartz crystals, very often amethyst, which is purple quartz, which is quartz with iron in it. And so what happens is you get this void in the rock, and flowing through cracks in the rock, you have a fluid, which is not lava. It's actually superheated water that's carrying dissolved amounts of minerals, including quartz, and you can have other things in there too. And as it goes through, it's depositing onto the walls, little bits. And under the right conditions, it deposits slowly enough that you get a nice, beautiful crystal growth. Just like when you're under the right conditions, you've got sugar dissolved in water, you can make rock candy. If you've got it, you heat up your water, you add lots and lots and lots of sugar, and you let it cool very, very slowly with a string in it, you'll get rock candy growing on it. Well, you don't have a string on it. And you do it, and you really, really don't care about getting mom or dad mad at you for ruining the pot because it's full of rock candy. You can actually have a geode of rock candy. Really, really hard to clean, though. Like, really hard. But it actually forms just about the same way as rock candy. It's this fluid that's cooling and allowing the dissolved minerals to precipitate out onto the walls of the geode, and they grow inwards to make the crystals. And sometimes they'll grow totally solid, and those are not as exciting, so you don't usually see those at the gift shop. And sometimes the fluid will either change in form, so it doesn't keep depositing, or it actually dries up and stops flowing, and you're left with a void that has crystals and then empty. And then somebody finds that and carves it out of the rock, and they bring it and they chop it in half, and then they sell it at the Science North gift shop. And the Dynamic Earth gift shop. Can't leave them out.
And sometimes, though, when you get those crystals, they've been colored and they're kind of weird, right? The actual crystals, aren't really quite the right color that they're supposed to be.
That's true. If you see them like a bright blue-green, like a turquoise color, quartz crystals never come in turquoise. That just is not a real thing. That's been chemically treated to make it look prettier. But if you see it like a deep purple, or a blackish brown, or a light yellow, that one's particularly rare though. Those would be real colors. Different sorts of quartz, for example.
Yeah, I've seen some pretty interesting when we go to gift stores. I'm like, that one doesn't look quite right, but you can get some pretty neat ones, that's for sure. We have an amazing one on display on our second floor, which is a huge amethyst one that's like it's ginormous. It's huge. You got to come and see that.
A small child could probably climb inside it.
Yeah, it's amazing.
We'd rather you not, but you would fit.
It's a really neat geode. Robin mentioned in our comments, they mentioned that Tyler seems to know all the random answers to all the random questions that we have. And Tyler's kind of like a little bit of a walking encyclopedia. If I ever have questions, I'm always like, hey, Tyler, do you know the answer? Because
I've already learned so much.
Right. Oh, this is great. Oh, man. So we're going to continue on just because I think people now know that we don't have a geologist here And so they're trying to stump us. Now they've got us. So Tara Matt is asking, what is the softest crystal? Ooh, and when we say crystal, that's hard. Like, I know I can kind of think of some really soft minerals.
If it's a mineral, it's a crystal. So
is it? Yeah?
Yes.
I don't know.
That's sort of part of the definition of mineral, is a crystalline, naturally occurring crystalline solid.
Yeah.
So if it's a mineral, it's a crystal. I'm trying to remember the hardness scale, so they might get me.
Renata, you're gonna have to do the work on this one behind the scenes to make sure that we're right, I think.
I do believe it's graphite, because graphite, being irregularly structured, it's regularly structured, it's naturally occurring, it's very soft, but it might be talc, so I could be wrong.
If I had to guess, Tyler, I would have guessed graphite as well.
There we go.
Okay, we got 2 votes for graphite, so if it's not,
talc is really soft too, though.
Oh.
Tyler, you got stumped. What is it, Renata? Renata's got the, oh no, it is talc. Talc was the answer. Oh my goodness. Well,
Melissa said talc though. So
I think I'm gonna give it to Tara and Matt.
Okay.
That is definitely woohoo. So Tara Matt Thompson, you did it. You stumped our scientists today. Great job. We're going to, if you want, you can write in the comments what names you would like to put on the stump. We would be more than happy to change the name, but let us know. But we're definitely, there you go. We're definitely going to engrave your name on the stump here. They're joining us today, so thank you so much. All right. 1 stump today. That's not too bad. That's not too bad. Yeah.
Amy, we're going to have to let Jen know, because Jen,
I know.
Yeah, she's going to be disappointed in us, I think.
our geologists over at Dynamic Earth who weren't able to join us today, they're going to be a little disappointed in us, but that's what are you going to do? All right. Let's see, what else have we got in this? If you haven't put your question in, now is the time to absolutely do that. Put it in right in the chat. This is kind of a neat one. When we were talking about black holes, if I was in a black hole, what would I see? Like, what would be around me? Be there? Would I even know I was in a black hole? I don't know. Speaking of consciousness, like, would I even know I was there? I don't know.
Seeing as all of your atoms would be crushed into an infinitesimal point, no, you wouldn't know, because you'd be dead.
I was going to ask that. Would you even be alive at that point?
No. Unfortunately, you couldn't survive the descent into the black hole. And then once you're inside, you're absolutely not going to survive the conditions there. But if we could imagine, being in there, some disembodied mind that has consciousness without any nasty atoms that have to deal with the laws of nature, what it would see is a good question. I don't think anyone knows, because, to be honest, the rules sort of start to fall apart once you get inside of a black hole. That's where our understanding of the laws of physics, because it's just so out there, it's so weird, the black inside of a black hole, the laws start to break down and not particularly make sense. There's actually one theory, a fellow named Dr. Lee Smolin, I believe he's still at the Perimeter Institute in University, or it's not at the University of Waterloo, but it's in Waterloo, Ontario. It's an independent research institution. Anyway, he's got a theory called loop quantum gravity. And in that theory, every single black hole that forms on the other side of it or on the inside of it is actually a Big Bang to make a new universe with slightly different physical laws. So you could say if you were inside a black hole, you would be inside a universe. And so you could see anything. Right? So maybe you're inside a black hole right now. Who the heck knows?
That's hurting my brain a little bit. Maybe
Hope I
we're
can
all
say heck on here. Uh-oh.
we're all just inside a black
So you're
hole.
telling me reality is even stranger than fiction? Is that what you're trying to say? Ooh.
Sometimes it might be, yeah. Certainly theory is stranger than fiction anyway. I don't know if that's reality. It's just a theory so far.
Oh man, yeah. Robin's like, why do you know this? I'm like, well, I don't know. This is what we talk about as blue codes around, like, you know, the lunchroom table and things like that, right? That's like blue code talk. If you ever wanted to know, this is kind of that episode. It's like, you ever wanted to know what blue codes talk about at lunchtime? This is what we talk about. Oh, that's great. Oh, this was a great one from MJ. Does a butterfly remember its time as a caterpillar? Like, does it remember being a caterpillar? Does a butterfly remember what it did 5 seconds ago?
I'm not gonna lie. I don't know what studies have, if anyone has studied this before. This is, I mean, that would be sort of like asking if you remember being inside of your mother's womb. Like,
I have vivid memories of this. No,
you have vivid memories, yeah. Like that's how I would equate it, just because, like, the whole structure of the caterpillar is basically taken apart and then put back together as a butterfly. Like, they become like a soup of molecules, and then they get restructured into a butterfly. So, like, their brains too, I'm assuming. Like, I have no idea, but I'm not sure if there's an answer to that one either.
Yeah. Renata, I'd be curious if you would Google, if this would help us, if you would Google, do butterflies have memory? Because that might be a good thing
They
to
must. I'm going to vote that they do.
Yeah.
I'm quite certain that they do. Monarchs must.
Yes, but well, no. With monarchs though, there is a gene. So, and there's different. So, like the monarch butterflies that go from Mexico back up to Canada, for example, there's actually multiple generations, and it is genetic, sort of, that tells them to go there. But the generation that leave Canada to go back down to Mexico, or wherever they're coming from, and go back down for hibernation, that is the super generation. Again, it's a genetic trigger that gives them longer life. But so it's possible that butterflies have a memory in terms of like where they go for the best food, but I don't know if they can remember being a caterpillar. And that was the question.
Yeah, that's
right. The question wasn't, do they remember things? Because I'm thinking, like, there's this genetic memory in the monarchs, but do they specifically remember are they smart enough to remember being a butterfly? Like, that goes back to, what do they know about themselves, which is the consciousness question and brains. And it's like, I don't think science is able to figure that out yet.
Yeah. Renata's told us that she can't find an answer. So I'm not quite sure if there is an answer, because I don't think we know. But you know what? I think that's a real, like, and if you're interested in studying butterflies and other creatures or the brain, that might be a really great question for you to figure out as a future scientist. So yeah, like, these are the questions, right? When we start thinking about things, it's kind of like, well, you know, that's how scientists start, is like, I wonder if this is, you know, a case, if this is a thing. Do butterflies remember? And could we, you know, do an experiment to kind of figure that part out, right? And very good question, though. I like the thinking. This is really, really, really good. All right. We have another question here, which is, how does the Earth have an atmosphere? The atmosphere that surrounds us every day and protects us. You know, how did that come about? Because there are planets that don't really have a great atmosphere, right? Like,
in fact, of Earth size, you know, okay, Mars is a bit smaller. It's a little over half the size of Earth, and it's got less than 1/10 the atmosphere. Mercury, no atmosphere at all. Moon, no atmosphere. Venus, well, it's Earth size, and it's got like 40 times the atmosphere. So it's like, okay, maybe it makes sense then that Earth has an atmosphere, but why is it, then the question is, well, why doesn't it have as much as Venus? So Earth's very special when it comes to atmosphere, which makes it very lucky for us, right? So the Earth's atmosphere, believe it or not, it comes a lot of it from volcanoes. So going back to geology, so when the Earth was new and young, there was a lot more volcanic action. And volcanoes don't just spit out lava, they also spit out a lot of gases. And when the Earth was forming, these you had, the Earth formed from all sorts of space rocks coming together, smashing together, conglomerating. And some of them were made of plain old rock, some of them were made of metal, and some of them were made of ice. Those are the comets. Okay, and that all got trapped inside. And these volcanoes give off water vapor. Even today they do. And carbon dioxide and nitrogen gases, all of that. And comets have all of that in presence too. And so as comets continued to smack into the Earth, some of that just stayed on the surface. The volcanoes were belching some of this out from underneath. And thankfully, the Earth has a nice, strong magnetic field to help hold enough gravity to help hold all of this stuff in place, which is one of the key differences, actually. Like Venus, for example, it has a very big atmosphere and no water in it to speak of. The reason it has no water in it to speak of is because it doesn't have a magnetic field like Earth. And so without the magnetic field like Earth, it's getting radiation from the sun that breaks up the water molecules high in the very top of Venus's atmosphere. When it breaks those water molecules, water is H2O. The O stuck around and actually sunk down and rusted the rocks on the surface. But the H's, being light, were actually carried off into space, gone forever. And so Venus lost its water and became a very weird place. Earth has a nice magnetic field, makes a compass work, and gave us some lovely water in our atmosphere. You got to remember, it's not just on the surface, it's also, especially on a muggy day, you really know it, but even on the dry days, there is water in the atmosphere. It's an important component.
Just want to add one thing to that. So you got to keep in mind that early Earth, just as Tyler mentioned, had very dangerous and poisonous atmosphere. We wouldn't be able to survive there. In fact, most of the life that you see on our planet right there wouldn't survive there. And one of the reasons that we have the atmosphere that we have, and especially with the oxygen levels that we have, is because billions of years ago, and even today, they're still doing it, there was a certain type of bacteria called cyanobacteria that started to use water to do photosynthesis. So some of you know what photosynthesis is, right? Take light energy, take components of water, and then make sugars, those type of thing. Well, as a byproduct of that, you're releasing oxygen. And because of those organisms billions of years ago, it really drove what we see as life here on our planet. So if it wasn't for them, you wouldn't be here, I wouldn't be here, and all the life forms that you see right now wouldn't exist. So that is why we have the atmosphere that we have right now, because we had stuff that happened in early Earth, but then life itself transformed our planet into a form that we see right now. So it's incredible to think that, this little bacterium billions of years ago really drove what we see today as our planet.
If you want evidence of that, we've got some lovely rocks at Dynamic Earth to show it off. They're called banded iron formations. And what it is it's showing the bacteria, these cyanobacteria, learning to photosynthesize, learning to live with the oxygen, because oxygen was a terrible pollutant that killed all life when it first got started. And this was actually the first mass extinction where all sorts of things, for the very first time, just couldn't deal with the evolution. Now, yeah, it's all microbes at that point. Life hadn't evolved beyond single-celled organisms, but it was a mass extinction of single-celled organisms. What we see in the rock record, these banded iron formations, is you have bands of iron-rich sediments, sediments being mud, right, from the bottom of the oceans, been squished to make rock over millions of years. And when there's a lot of cyanobacteria, they start getting going, they pump lots of oxygen into the oceans and into the air, it rusts the iron, and you have a red band. But then there's too much oxygen and they start to die off. And you have a dark gray band where it's iron and not rust. And then they start getting going again and it's red again. Well, eventually they learn to live with these higher oxygen levels that they're creating. So it's not these bands, but stripy rocks are cool.
Yeah.
And it tells the story in the atmosphere that Bruce is saying about how this is part of how we know these microbes change the atmosphere so much.
Absolutely. So really funny. Robin must have been watching our last To Stump a Scientist because, of course, water bears have come up as a topic once again. Couldn't live without them during a Stump a Scientist, but they're saying that maybe they could have lived on that very toxic planet that we have. Probably.
They certainly could have. They would have been able to. They might not have lived, as in run around and eaten and metabolized and had babies, but we could have dumped them off there and brought them home, and they would have been fine when we brought them back into the environment that they like. Remember, that's the special thing about water bears, isn't so much that they can live in any environment, but they can survive it.
They can survive. Oh, the tardigrade. That's like, I think we should just have a whole, you know what, Megan? One of these days we should just do a whole Stump the Scientist about tardigrades. I think that would be fantastic. So, all right, here I do have an update, everybody. Everybody, this is exciting. The update is we have another person who has stumped the scientist. So MJ's question about whether or not caterpillars have memory, oh my gosh, Renata has found a paper. She has dug deep into the scientific journals. And Renata, it would actually be really good if you could put that paper into the chat on both Facebook and YouTube. I think it's a great way to kind of connect it if you wouldn't mind doing that. So this paper, actually, we had scientists that did test whether or not butterflies and moths had memory from when they were caterpillars. And my quick read, because I just quickly read the abstract, but a quick read says that they do, but only from their later stages of being a caterpillar. So not so much when they were so almost like humans, right? Like I remember being 2-ish, 3-ish years old, but I don't remember being, 3 or 4 months old. So months old. So yeah, that's very cool. MJ, congratulations. You've stumped our scientist today. Your name is coming on to the trophy. So if you would like a very specific way to put that on there, make sure you put it in the chat. We'll find it. So absolutely. Thank you very much. That was a great question. I really enjoyed that one. So thank you so much, MJ, for that one. And we are getting really close to time. We are going to take one more question. I just have to figure out which one this could possibly be. Oh, we got lots of space questions. Lots of people wanting to know about aliens. Oh, let's see, though. I found some really good ones. Oh, this was a really good one. This is a great way to finish it off, and I'm happy to take this one on because this is my kettle of fish, is that what is the deepest part of the abyss? And so as a marine biologist, this is something I definitely know. So the deepest part of our oceans, and our oceans are incredibly deep. They're much deeper than I think most of us, even can, fathom, that's funny, fathom and imagine, right? Is the deepest part of our oceans is just over, like a hair over 11 kilometers deep. So look at Bruce's eyes, 11 kilometers. So I think of, all right, so I live in Greater Sudbury. And for those of you who might live in Greater Sudbury, I live in the town of Dowling. And in order to go to, get to Science North, I have to drive through a whole bunch of different towns. And the next town that I have to drive through is called Chelmsford. And it's 11 kilometers away from Dowling. And that, if you take that long and go, and look at this way, that is the deepest part of our oceans. It's located in the Marianas Trench, which is this huge, long trench, and finds some of the deepest part of our oceans. The best part of that is that there are still animals and creatures and other organisms that live that deep in our oceans. And I think that's, I don't know.
Two worms, Amy. Two worms.
Two worms. Absolutely. Absolutely. And what's really neat is some of the deepest parts of our oceans too have animals and a whole ecosystem that doesn't require sunlight in order to live. And it's the only type of ecosystem on our planet that doesn't rely on sunlight and photosynthesis to live. They rely on the chemicals that are coming up from the inner parts of our earth, and they're synthesizing things through the chemicals through that. So chemosynthesis, which is really, really, really incredible, because for the longest time, scientists thought that the only way life could happen would be through the sun. And now that we've been able to, get to those deepest part of the ocean, now we know that life can exist in a totally different way. And Tyler will tell us for sure that means that there's greater chance, when we talk about aliens, because we got lots of questions about aliens, that means there's greater chance for life to exist on other planets that are not dependent on having vast amounts of sunlight available to them. So that to me is a pretty interesting find, and that's for sure. Well, thank you everybody for joining us today. This has been a wonderful version of Stump the Scientist. Thanks for joining all of us from all of us at Science North. Tara, Matt Thompson, and MJ, you have both stumped the scientist today, so congratulations. You're with school today, so MJ, you don't have to do anything. We'll just write your name. Actually, I'll write it in really cool MJ letters. And if you ever come to Science North and want to come and visit us, your name will be on that trophy. And same with Tara, Matt. Your names will be on that trophy as well. So thank you very much, everybody. We're very excited. And you never know when there'll be a next chance for you to try to stump one of our scientists. And I hope we'll see you soon. Thanks, everyone.
Bye.